Okay, so we have started chapter 2. As I said, we have started chapter 2 in the last class, along with section 1.5 of chapter 1, that is layering concepts. We have covered section 2.1, that is the basic concepts about application layer. So let me just review what we have covered. Okay, first point we have discussed is that network applications are the programs or software that run on different end systems. So when we say application layer, we actually deal with what part of the internet? Can anyone say what part of the internet when we talk about network applications? Network is, right?
It's a network itself.
All applications, right, it works at the network edge. That means network edge contains only different types of end systems. So why that is important? Because as a user of internet, we normally connect to internet using end devices, and we use different network applications. There is no need for any application for network port devices or intermediate devices. Definitely there are some programming software also, because we know up to network layer all implemented in software, and then upper half of data link were also implemented in software. Only the lower half of data link plus physical is hardware. So definitely there are other softwares, but we can think about network applications that is used by the users in the end systems to connect to the network. Then we have described like application layers actually communicate between end systems, and all end systems are part of the network edge. And then we have described two types of architectures or paradigms. One is called client server architecture, and another one is peer-to-peer architecture. Like there are some uh, properties, different properties. Most significant property of client server is the server is always dedicated and on, and server has a fixed permanent IP address. And the third one was there is no direct client to client communication. And for the peer-to-peer, there is no always on dedicated server. The first point. Then any node can come on and off. It is not mandatory to have a fixed permanent IP address. And the third point is there is direct client to client communication possible. So the main advantage of peer-to-peer is self-scalability. So new peers join and leave. There is no fixed thing about any particular client or server. And
So which one should we
file
use the most?
okay, there is no answer like which one is better or which one will be the most. It depends on what type of requirements you have. Normally when you do web browsing, right, we must have a server at the other end. Otherwise, how can we connect? How can we request, right? So that is client server. Like we use facebook.com, google.com, we send emails. Okay, so all are client server because there must be server to which client will request. But there are other cases like in your home, at your home. Okay, what you will do if you need to connect your maybe you have one PC, one laptop, maybe you have one tablet PC. So you might have multiple, but at your home you just need to connect them to share resources, right? You don't. Uh, you can configure a particular server, dedicated server, but that is of not much use at home. You need to copy anything from any device to any other device. So in that case, what you will do, you will just connect your PC or laptop using a hub or switch, and then you just share a particular directory or directories with other PCs. Or you can install a printer, right, to a particular PC,
Yes,
and
sir.
you need to print from other PCs. So in that case, what you need to do, you have to share that printer from the installed PC so that other PCs can use. So these type of examples are actually peer-to-peer. And there is actually larger requirements, like uh, some applications are there where users share resources, like, although some of them are illegal, and that's why they were obsolete. Okay. Because for example, I have 10 movies, then I share the 10 movies to others, and they have another 10 movies, so they can share to each other, and they can search anything using a software and then copy from other PCs. That is one example of peer-to-peer architecture. Okay. And also very good example is torrent. You know torrent? Anybody know
Yes, sir.
what is the idea of torrent in short? Shada, what is the idea of torrent? Any idea?
স্যার মানে মানে এটাকে কি জানি বলেছে, মানে কেউ একটা ফাইল শেয়ার করে মানে কোন একটা
The
পার্টিকুলার সার্ভারে।
main idea is, yes, actually the idea is file sharing, but the primary idea is, the primary idea is actually to make it parallel. So whenever, suppose I download a 100 megabyte file, a user downloads 100 megabyte file, and when 20 megabytes already downloaded, then that particular host or end system can act as server for others. So what is the advantage? Instead of downloading 100 megabytes full from one particular source, I can download from 10 different sources, from 5 different sources. So parallelism is increased, and at the same time there is no burden on one particular server. So this is the advantage of torrent. But see, this idea comes from peer-to-peer architecture. So any node can be a client when it downloads a chunk from others, or it can act simultaneously as a server when someone else is downloading a chunk from that piece. Is it clear?
Yes, sir.
So that is the idea of torrent, but unfortunately we'll not go to very much details on peer-to-peer because of lack of time. We'll mainly concentrate on the applications that we mostly use, like web browsing, like email, like DNS, domain name system. Those are all client-server applications. Okay.
Sir,
Yes.
I have a question.
Yes, Fazila.
Sir, in peer-to-peer to pressure, like the overall security system is weak, right? Like because each system is independent, I think, and contains its own data. So what about the security? Like, I'm just curious, sir.
Okay. I think it's a good point, but again, the same thing. Security, definitely security is easier to implement in client server, maybe because the server is the dedicated, and the server is the point where all clients connect. So if I can make sure the server is secure, then most of the security requirements fulfilled. In case of peer-to-peer, since anybody can join, but it does not mean that you cannot implement security in peer-to-peer. You definitely can implement in security peer, but this is more challenging. So the point is right, that is more challenging here. But which one is secured? Again, there is no answer. A peer-to-peer system can be secured, and also a client server can be not enough secure. It depends on how you implement and how much measurement you have taken for the security purpose. Okay. So right now we are just discussing about different types of architectures, not about exactly which one is better or which one is more secure. You cannot answer it directly unless you know what are actually implemented in that particular system. Okay. Okay, then also we have started, in fact, the process communication, and we said there are two types of process communication. One is communication of two processes, but both residing in the same host. Like we can copy a text from MS Word, we can copy to PowerPoint, right? So it is copied. But this is not networking. This is maintained by the operating system using a common memory. So what is networking? When two processes reside in two different physical machines. So whenever we communicate from one process in one physical machine to another process in a different physical machine, then we call it networking. And how that is happening? By exchanging what? Messages. So it is also true for human communication too, because when we communicate with one another, definitely we exchange messages, maybe through our voice, maybe through our gesture, maybe through some other means. Okay, so similarly, two processes in two different machines will communicate using messages, and then one process we call it client process, who initiates the communication, and then another process is a server process who actually started and then waits to be contacted from the clients. So this is common for all types of uh, communication in networking. Then another concept, this is also you have covered in the last class, the basic concepts. Will not cover it in the programming level, that will be covered in the computer network lab. So in the theory, just I am giving you the concept of a socket. The socket idea is it is analogous to a door. So whenever we just want to go from room number 1 in a building to room number 4, definitely we must use a door, right? So room 1 and room 4 are connected through different doors. So the same idea is socket, and rooms are like processes, applications. So two processes, two applications in two different machines, as you can see in this diagram. So we can call those applications as rooms, applications or processes as rooms. And then if we need to go from one room to another room, we need to use a door. And this door, in case of uh, programming, is socket.
স্যার কিছু শুনতে পাচ্ছি না।
স্যারের মেবি কানেকশন প্রবলেম, চলে গেছে।
Hello? Can you hear
Hello,
me?
sir. Yes, sir.
I was disconnected, right? I was disconnected from my laptop through which I am actually giving lecture.
Oh, sir, we did understand that.
Oh, so just my screen was not shared, right?
Yes, sir.
Yes, sir.
Just
Yes, sir.
You
at least
then you were
respond.
like disconnected.
Yes, just in this case, just respond using a message box, because I was not sure. I also didn't look at the other window, my tab. So that's why I was asking some questions, but I got no response. Suddenly, I thought I'm disconnected. Um, so which slide I was before being disconnected?
So
Sir, slide
sockets.
14.
Slide 14. Okay, this slide, right? No,
Yes, sir.
Yes, sir.
this one. No, not this one. I think I didn't start.
The socket. Oh, not
Socket, sir.
Okay, so it means this one.
This one, sir. This one.
Yes.
This one.
Yes, sir.
yes, sir.
Oh, I think then it's a long time I was disconnected. I was just
Yeah,
continuing
you were
the.
disconnected for a long time.
Oh, okay. Anyway, uh, actually this part we have covered in the last class. I was reviewing. Then I started the new lecture, but unfortunately I was also not aware that I was disconnected. Anyways, sockets is the concept, that is a programming concept that is used by application and transport layer as an interface. As we say, transport layer takes data from multiple processes, so it must differentiate each application's data separately. Okay, so in that case, for each application there is a socket, and every socket is identified by a port number. I think this is also I have discussed yesterday, last class. Port number. So port number identifies a socket, and then to connect to a server, for example, a web server, in that case, we need to have both identification. One is the IP address to identify the device, and at the same time, to identify the particular application in that device. Okay. So for web application or web browsing, we use the port number 80 for the server. But as I said, there are actually two sockets in two sides. In the client side, there is a socket. In the server side, there is also a socket. But server side started first because server will start to listen. Okay, so server side socket is actually called well-known port numbers used by the sockets, and client socket port number is a different one, and that is actually defined by the operating system. But when we say HTTP uses 80, we say actually HTTP server uses port number 80. Similarly, when we say email server uses port number 25. So every server has a IP address definitely and corresponding port number for a particular application. And whenever a client needs to connect to a server, client needs to use both IP address and port number. That is specified here. And
Yes, sir.
this also covered in the last class. I think we have discussed about different things defined in application layer protocol. There are 4 things. First one, types of messages. Like in HTTP, there are only 2 message types. One is HTTP request, one is HTTP response. We'll see shortly. Then syntax. Syntax means actually the grammar. That means the format and order of messages. Which field comes first, which field comes later. Then semantics. It is the meaning of a particular field. For example, when you say IP version 4 address, that is 32-bit. When you say IP version 6 address, that is 128-bit. So you have to have the same required value. That is the semantics. And finally, definitely the actions, the rules, what to do when receiving a message. Okay? And there are some open protocols, and there are some proprietary protocols. Open protocols means these protocols are defined and the definitions are available publicly. So you search for example, HTTP protocol. These are defined as RFC. RFC means request for comments. So every protocol has a corresponding number. For example, RFC 1800, RFC 1915, right, like this. So you search that, you find that available in the internet, you download and you can see. That is open protocol. All the things are defined there. But there are some proprietary protocols like Skype, where they don't disclose their protocols. They just keep it among themselves. These are proprietary protocols like Skype. There are some other proprietary protocols. And also we have described four different points, the data integrity, timing, throughput, and security. Data integrity means no data loss is tolerable. For some applications, actually, let us make sure you understand this. These are the 4 points. Every application needs to think before deciding on which transport layer service they want. Okay, so first one is data integrity or data loss. For example, when you download a file, no data loss is tolerable, right? If some bytes are missing, that is a problem. So that is data integrity. Then for some applications like audio, multimedia, some loss is tolerable, but no delay is tolerable. Timing must be strict, like internet, telephone, interactive games. Then throughput. Some applications need minimum throughput, minimum transmission rate, like multimedia game. But for file download, if you have larger throughput, it will take less time. If you have less throughput, you will have more time, but it will work. So these are called elastic applications, elastic. And last point is security, encryption or data integrity. Application must decide whether or not it needs security. For example, you know HTTP versus HTTPS. HTTPS both used for web browsing, but HTTPS is secured HTTP, whereas HTTP is default HTTP. It will work, but it will give no security. So any application layer must think these 4 points to decide what type of service will take from transport layer. And there are 2 types of service. One is TCP, one is UDP. We'll go through details of these services in chapter 3. Right now, we need to know just the concepts. For example, TCP is a reliable transport protocol. That means if some data packets are lost, TCP will ensure those are retransmitted. So that is reliability. Flow control, receiver can receive at a particular rate. If sender continues to send more than that rate, then receiver will lose data, right? Data will be getting lost. So flow control means, now one thing you have to make it sure that this feedback, acknowledgement from the receiver. Unless getting acknowledgement, this cannot be implemented. So flow control means receiver will send sender the amount of free space it has after receiving a particular segment. So sender knows, okay, I cannot send more than this amount of data, otherwise packet will be lost. So this is flow control, right? Congestion control similar, but it is not only receiver's buffer. It is like whenever a node can transmit at a rate and receive at a higher rate, then what will happen? The node will line up in a queue, store the packets in a queue, but still the memory is limited. So until if it continues to receive continues to receive at more rate, then at one time the buffer or memory will be full, right? Then what will happen? That will be lost. So congestion control means to control the jam, traffic jam, the packet jam in a way so that nodes will send at a rate, jam will not continue. That is condition.
Buffer will not full.
Shahadab, any question?
No, sir.
Okay. So
Sir, how
this
is
is the
the
basic idea about TCP.
sir? How is this
How-
congestion
how-
detected, sir?
What?
How is this congestion detected?
Sorry. Oh, okay, okay. Rifat, actually this we will study in chapter 3 in details. Because
Okay, sir.
the detailed mechanism will say how that is done. But see, the logic is, if a node sees, okay, if I send 10 packets per second, I got 1 or 2 packets lost or 1 packet lost. Then what it will do? It will reduce the rate. 5 packets per second. That is the basic, very simple. But how there are lots of algorithms how congestion control can be done. And in fact, this is a huge research field still in different networks, how congestion control can be done. But definitely TCP does that because TCP gets a feedback. On the other hand, UDP, the main characteristics is it will have no feedback. No feedback means what? No extra data. No extra data means definitely it will take less time, right? So that is
Faster.
the idea of UDP. But since it will not, right, that definitely it will be faster. But the problem is, since there is no feedback, it cannot ensure reliability, it cannot ensure flow control, it cannot ensure congestion control. So if you have lower bandwidth, then UDP might not be useful. Okay, but still, if you want multimedia applications, voice, in that case you definitely need UDP. Otherwise, time will be higher. But both the cases, TCP and UDP, will not provide any guarantee. What guarantee? Any timing guarantee, any security. You have to implement an application layer has to implement this using a separate mechanism. For example, HTTPS, secured HTTP. Actually, in this case, between application and transport, there is a mechanism implemented called secured socket layer. Okay, or transport level security. I think some of you have heard SSL, secured socket layer, but that is not content of our in this course. Maybe when you do a network security course, you can get an understanding of how that security works. Okay, so that was actually the basic concept, section 2.1. Irrespective of any particular application layer protocol, how these applications actually behave, or how they are related to the transport layer side. Now we will start one by one. The 3 application layer protocols we will study in this chapter. First one is the mostly used web browsing that uses HTTP protocol. Then we will study email, and then last we will study domain. Okay. I think all of you have used HTTP, right? We are continuously browsing internet. So many things you can connect if you want. First thing you need to remember, we browse internet means actually we browse what? Web pages, right?
Yes, sir.
We click a link. That means a web page is requested. That web page comes, and we have already shown one example, I think in the first or second class, where
First class.
we have shown that, right, first class, we have shown that, okay, when we write an address in the browser, then what happens? A request is created and sent to the server. Actually, that is HTTP. And the message generated by the browser is HTTP request. And then server examines what is requested. Okay, I got the file. Then server will send the file with the HTTP response. That is the basic idea. Now in this section, we'll go to more details. So first thing, web page consists of objects. What type of objects? Each of which can be stored on different web servers. You have experiencing a web page uploaded with, for example, 10 images, right? With, for example, now a Facebook page contains images, contains different objects, right? Video, audio. So there are different type of objects in a single page. So web page is a container, and the basic template is HTML. And the HTML page actually contains different objects. Now what that means? That means if you download an HTML file, that does not mean that that is a single file. If there are 5 different images, then all 5 images are in different files, right? So if you browse a web page with 5 different images, how many objects are there?
5 objects.
5 plus 1.
1
Because
HTML file.
Right, the base HTML file. So make it clear. If there are 5 images, 2 video, 1 audio, how many? 5 plus 2 plus
2
1
plus 1
8
plus
1
plus 1 9.
plus 1. Right, 9. So keep in mind, web page consists of objects, because if we want to understand HTTP, we need to know that this is the first thing. So object can be HTML file itself. It can be JPG image. Also, it can be programming code. Your code is running. You know, JavaScript is
Yes.
built in the HTML, right? So that is also an object. So HTML is a container. Web page is a container. Now, how can we access those objects? Using URL, Uniform Resource Locator. And you can see here, a URL has 2 parts. One is host name, like www.summischool.edu or facebook.com or google.com. Then the file itself, that is the path, like slash, then maybe news, then slash news1.html or some image or anything. So first you have to identify the host, and then you have to identify a particular file under that host. So that is URL, right?
Yes, sir.
Yes, sir.
Okay. Now, hypertext transfer protocol, how it works? There is a client, there is a server. This first thing, this is a client server protocol. So this is a client server protocol. So our browser is a client and server is running, and then client can run Firefox browser, client can run Safari, Opera, client can be a PC, client can be a laptop, an iPhone, any, and the server running a separate program like Apache web server. There are different versions of web server. Again, that Apache web server is an application or process, and the browser used by the client is an application. So how this works? Like this: HTTP request response, HTTP request response. So it doesn't matter what is the hardware, only 2 messages are exchanged: HTTP request and HTTP response. Second point, HTTP uses TCP. That means what? That means HTTP is a reliable protocol. So whenever an application wants to implement reliability, that must use TCP, right? How that uses TCP? Initially, clients initiates a TCP connection to server at port number 8. Any application using TCP must establish a connection before data transfer. So the first thing, TCP connection. Second thing, now server accepts the connection, and then client will send HTTP messages. What is message? HTTP request. And then server will send HTTP response. And after that, the connection is closed. So it is continuously happening. HTTP request, response, request, response, request, response. And one thing is saying here HTTP is stateless. Stateless means what? When you click a link, did you notice when you click a link, did you see what is actually specified in that link? If you just keep your mouse there without clicking, you can see a status in the lower status bar, right? And that shows actually the path or the URL of that particular file. Did you notice that anytime?
Yes, sir.
Yes, maybe some of us didn't notice that, but from now on, since you are a computer network student now, so you should notice what is happening. Now, if you click there, sometimes it happens, right? If you download a file, maybe it is responding slow, so you click 3 times. See, I think many of you have experienced this. So you click 3 times, then what happens? Okay, file.html, file 1, file 2, file.html 1, file.html 2. It happened, right? So you 3 click actually work, but since it responded slow, you didn't notice that I have already clicked and it is getting downloaded. So 3 window comes, right? That means what? That means when you click in a link 10 times, HTTP reply will be sent 10 times. It will not check whether or not you have already clicked once. Okay, so that is called stateless. Stateless means it will not verify whether or not the same link you have already clicked. Right? Sometimes what happens, this is HTTP is stateless to make it simpler, and sometimes what happens, you need to make HTTP stateful. It need to keep state information. Okay, so that past history you can use. For example, when you go to e-commerce site, right? You just log in, and then they give you some suggestions, right?
Yes, sir.
That means what? That means they identify you. Without being stateful, they cannot identify you. Without being identified, they cannot. Without being stateful, they cannot identify you. So in that case, you have to use some other mechanism. For example, you heard about cookies, right?
Yes, sir. Cookies.
Not biscuits. Cookies, different mechanism in networking to identify the client. But we are not going to do this in this course. Just to make it stateful, they use cookies. By the way, cookies can be misused. Cookies can spy your machine. Cookies can transfer information, unauthorized information from your PC to other PC. So this is one thing that cookies can do. So that's why sometimes we just stop cookies. Okay, now there are 2 types of connections. See what we said here. Client establishes a connection, request response, then client connection closed. But if you have 10 objects, then maybe each time you establish a connection, you transfer a file, again you have to establish a connection. Establish a connection will take time, right? So there are 2 versions of HTTP connections. One is called non-persistent. Non-persistent means when every new object request needs to establish a new connection. And persistent means once you establish a TCP connection that persists, that means for any number of objects, you can use the same connection. You got the idea? So which one is more efficient according to you? Non-persistent or persistent?
Persistent, sir.
Why?
Because we can send multiple objects in the same connection.
Same connection. That means you don't need extra time for new connections, right? So
Yes, sir.
definitely persistent will take less time, but again there is no better. It depends on which HTTP version you are using. If HTTP version 1.0, that only uses non-persistent. HTTP version 1.1 or later, like I think 2.0 is common now, even 3.0 is being used. So in that case, persistent you can use, but suppose one client is using 1.0 and server is using 1.1, what you should do? You have to go to 1.0, right?
Yes,
Because
sir.
1.0 will not support 1.1, but 1.1 can support 1.0. That's why you cannot eliminate non-persistent still. It depends on both sides must agree. But there are two types. Now there is an example which will make it clear. For example, you click a particular link, you see on top that contains text and also reference to 10 different objects. Okay, 10 different JPG
JPG
images.
images.
Okay, now how many objects are there?
11.
11. Very good. 11. So 11 requests must be sent. Even if as a user we click once, then when my browser starts displaying, then it first actually downloads the base HTML. Then it finds out there are 10 different image objects, each of which is where? In the client or in the server?
Server.
Very good, in the server. So for each different image, it needs to send the request again. For 10 different images, 10 requests, 10 responses. But one thing I think we should understand, without downloading the first HTML file, client cannot know, right, that there are 10 different image references. So now, in case of non-persistent, see 1A, 1B, that means the TCP connection is established. Okay, HTTP client initiates the connection to the server, server responds, accepts the connection, so only connection is gone. Now, in 2, the request will be sent. In 3, the response will be sent. In 4, what will happen? So
The request.
connection will be closed because this is non-persistent. Only one object can be sent through one
Oh.
TCP connection. For the second object, you have to establish the
Connection.
right. Is it clear now?
Yes, sir.
Okay, now
Yes, sir.
step 5 says for the 10 remaining JPG objects, you have to repeat 1, 2, 4. Now what will happen when we convert this example to persistent? Where will be changed? What step will be changed?
Step 4, sir.
Very good. Step 4 will be changed. Step 1, 2, 3 will not be changed, right?
Yes, sir.
Step 4 will be changed. And what other step will be changed? Step 5.
5, sir.
Because now the repeat will 4 will be actually 4 will not be there. Because once the TCP connection is established, any number of objects can be sent. But in step 5, we will only repeat, sorry, step 6, I'm sorry, step 6. In the previous case, non-persistent, step 1 to 5 must be repeated. In case of persistent, 4 will not be there. So 5 will be 4, right?
Yes, sir.
In that case, step 2 to 4 will be repeated. Okay. So no TCP connection, no new TCP connection. Now, how we can actually convert this concept into a mathematical format or a numerical format? We use one term called RTT, round trip time. What is the definition of RTT? Time for a small packet to travel from client to server and back. Not only client to server, but also the response should be back to the client, as you can see in the diagram on the right side.
Yes, sir.
Can you see?
Yes,
So
sir.
for the TCP connection, when it says it's small packet, it means what? It means if the packet only contains few bytes. Since in the TCP connection there is no data, only header. No data. That
Yes.
means these are small packets. So see, one RTT means a connection request and the response. That is one RTT. Again, after the connection is established, a file is requested, right? HTTP request. Now, HTTP request again is a small file because there is no data maybe. For HTTP response, at the end of the response, server sends the entire file. So that means what? That means that in thickness, see the thickness. The thickness here indicates time to transmit the file. Can you see here?
Yes, sir.
So the larger the file, the thickness will be more. So when we convert these to a numerical point of view, we can say in non-persistent, HTTP response time for one object will be 2 RTT plus file transmission time, right?
Yes, sir.
Anybody has any question? So in case of, since there is only in this diagram only one object is requested, but if I request for 10 objects, then what will happen? In
So
case of
10
non-persistent,
times.
right, 10 times. So in case of non-persistent, that is simple, 2 RTT into 10, right?
Yes, sir.
In case of persistent,
2 times, sir.
2 RTT.
1 RTT for TCP connection, right? 1 RTT for TCP connection, and then 10 RTT for 10 different objects, right?
Sir, in total 11 RTT.
Right, in total 11.
Okay, sir.
Because in case of persistent, we don't need this RTT again and again, only one time. So first 1 RTT. And for 10 objects, 10 different RTT, 10 RTT. But there is one other option. For these 10 objects, we say 10 RTT. That means we assume a new object request can only be sent after the response has come, right?
Yes, sir.
But if it is done in parallel, that can also be done. That is called persistent with pipelining. Persistent without pipelining means one by one. Persistent with pipelining means if there are 10 different references. See, now when our browser downloads the HTML and it says there are 10 different images referenced, right? Then it can send each request separately, one by one, and it can send 10 different requests simultaneously, right? Parallel. So that can also happen. I think we will do in the next class when we do hands-on exercises, that will be more and more clear. But right now, since we are not doing it hands-on, I'm just keeping it here as the concept. Not going to very much depth. But is it clear to everybody that for non-persistent, every object needs 2 RTT and then plus file transmission time, because it depends on the file size? Any questions so far?
Yes, sir.
That HTTP 1.1 and persistent HTTP 1.1 or later. Non-persistent is basically 1.0. That is not specified here, but non-persistent is specified by 1.0 only. Now we need to see the format of different type of HTTP messages. And there are 2 types of messages. One is HTTP request and another is HTTP response. One thing is common for all messages. All request messages or response messages are ASCII format. You know ASCII code. So ASCII format means that are human readable. So whenever using some packet sniffer tool like Wireshark, if you capture the packets without encryption, I think you can readily see the header. The things we study in theory, from the browsing history, you can collect and display the packets, you can see the headers in human readable format. That is one thing. And that is the request format. There is an example. You can see the first line. The first line is called request line, where there is the first component of the first line. There are three components, right, in the first line, request line. One is the method. The first one is the method, and there can be different types of method like get, post, head. These are called command or methods. Okay. Then /index.html, that is the path, the file path, and http/1.1, that is the version number. So this is the request line. Then you can see there are several lines. Those are called header lines, right? Header line. What is the purpose of header lines? Actually, header lines, using header lines, client can send some information to the server. For example, it says host www.net.cs.umas.edu. It can be www.facebook.com. So by host keyword, host header line, client can specify the server's host name or domain name. Then user agent. User agent means what type of platform client is using. See Firefox, Mozilla Firefox version number, it's given here. Will accept. See text HTML or different type of XHTML, XML. Client can specify what type of format it can accept, so that server will send that particular format only. Then accept language. Many of you have browsed different websites with different languages, right? For example, bdnews24.com. I think they have both English and Bangla. Anybody know that?
Yes, sir.
Anybody browse that?
I sometimes browse that.
If you go there, you can see websites, different
Two version, Bangla and English.
okay. The same news. So when you click Bangla, how do server knows that is Bangla? Right? Client must send the information. How? Using accept language. In this case, it is ENUS, but it can be Bangla, it can be some other languages. Okay, can you hear me?
Yes, sir.
Okay, I think network is getting some problem. Okay, so this is the format of HTTP request message, and every line must end with two special characters. One is carriage return, one is line feed. So that, because the header lines can vary. It can be 4 header lines, it can be 40 header lines, it depends. So how receiver will know that is end of a line or that is end of message. So end of a line must be specified at the end of each line, and end of message must be specified with a blank line with carriage return and line feed. Is it clear?
Yes, sir.
And there can be get is actually when we request for a particular file, but there are some other methods like post. You have used Google Form, right?
Yes, sir.
So in case of Google Form, that is different, because in case of Google Form, we add some values in different fields, right? And then we click submit.
স্যার একটু ডিস্টার্ব দিচ্ছে হয়তো কানেকশনটা, কথা আটকে আসতেছে।
Yes, sir. Same problem here.
right?
Yes,
And
sir.
when we send some particular link, or when you search using search engine, like you search. Hello, can you hear me?
Sir,
Yes,
I
sir.
can hear your voice.
Yes, sir.
Can you hear me?
Yes, sir. Now we can
Yes,
hear
sir.
you.
Yes, sir.
Hello.
Yes, sir.
Yes,
Okay,
sir.
I think
এখন শোনা যাচ্ছে।
network is giving some problem today. Okay. Okay, then another two methods. Head method. Head means only information is needed, not the file. And then put method is when we upload a file to the server, not the data. So you submit Google form, that is post. You submit a file to the server, that is put. It can be different methods used in HTTP request messages. Then HTTP response. So similarly, in case of HTTP response, there is a first line called a status line. So status line actually has again three components. First one is version number. Second one is a phrase, status code. Third one is a status phrase. So you can see 200 okay.
Yes, sir.
And then similarly, there are some header lines. Again, for the server to inform the client. For example, you can see date. There is a field called date. Date means which time server sends the response. Then there is a server field that specifies what type of environment server is using, like Apache 2.0, CentOS. Last modified. What is last modified? You know, server is sending a file at the end of the response, right? So
Yes,
last modified means when, what time that particular object is modified. So there is a
Yes, sir.
difference between date and last modified. Both are date format. But date is when the message is sent, and last modified is the object that is attached to the response when that has last changed. Here.
Yes, sir. Yes, sir.
Then content length. Content length means what is the total length of the message including data. For example, 2652 bytes. Content type. There are some other fields you don't need to worry right now. Just we need to know the most common because all these are defined in an HTTP protocol. Similarly here, end of line is specified by /r/n and end of header specified by a blank line with /r/n. And as you can see at the end of the message header, the data is attached byte by byte. Okay. Now, status code and status phrase. Did anybody see 404 file not found anytime?
Yes, sir.
Yes, sir. অনেক common.
Right,
Yes,
many
sir.
times. Many times. But did you see 200 okay?
No, sir.
No, sir.
No.
Two.
Why? Because 200 okay means the request was successful. 404 not found means the file was not found in the specified path. The 200 okay means file was successful, request was successful, so the file is sent and then browser displayed you the file. So that's why you don't see the code.
Okay,
right?
Mrs. Yes, sir.
Yes.
স্যার স্যার একটা এইচটিটিপি রেসপন্স দিয়ে কি যতগুলা অবজেক্ট পাঠানো সবগুলো অবজেক্ট চলে যায়?
Sorry.
স্যার if a website can have
Okay, if your website, because
if a website can have some multiple objects, maybe 10 image files, তো স্যার প্রত্যেকটা ইমেজ ফাইলের জন্য কি এক একটা রেসপন্স পাঠাবে
Okay,
নাকি?
okay. In that case, right. There will be separate response for every object because there will be separate request for every object.
ও ওকে স্যার, ঠিক আছে।
As a user, maybe we click once, but if the HTML contains 10 different images, our browser internally sends 10 different requests for each one.
ওকে
So
স্যার,
if there are n number of requests, definitely there will be n number of responses from the server.
ওকে
You
স্যার,
want to
ইয়েস
know?
স্যার।
So this screen specifies some of the common response status codes, HTTP response status codes, and there is another concept called conditional gate. What conditional gate actually does? It is normal, like normal gate, because in case of normal gate, what happens? Every time we send a GET request, server will send the file. But sometimes what happens, the client or browser may contain a copy of the file, and that is very recent. So in that case, sending the file from the server is inefficient. Before the last version. So client needs to know whether or not the file got updated, then the client's copy. Okay, so in that case, what client will do? Client will send a if modified since header line along with other things. All things remain same, but it will add a new header line called if modified since. Okay, if modified since, definitely if you see in any request message there is if modified since, that means client has a corresponding copy in the cache memory. Definitely, otherwise client will never send if modified since. This means it is saying to the server, I have a version of the file, but please see, this is the last modification date. So if you have the updated file, send me the file. Otherwise, don't send me the file. You got the logic?
Yes, sir.
স্যার
So see the diagram now. So if the object or file is not modified after that date, it should be after, not before. After that date, not modified, then server will send that, okay, 304 not modified. That means you can use your own cached version. I am not sending you the file. So that will save time. Clear?
Yes, sir.
And if the server object is modified, previous one said modified before, that is not modified after. So if modified after the date specified by the client, then definitely server needs to send the file, right?
Yes, sir.
So normal. At the end of the response, server will send the file itself. So this is how the conditional gate works. It is called conditional because it works more efficiently. If updated, then send. If not updated, then send only the header, not the data. Clear, everyone?
Yes, sir.
Okay. I think we'll cover email and DNS in the next class. Before that, we'll do some hands-on exercises in the first part of the class, and then we'll go to email and DNS. Any question up to this point? And hopefully next week I will give you our first homework assignment. You will have 1 week to submit, 1 week time to submit. So I will upload in the ELMS. Maybe before the Sunday's class or after the Sunday's class, because Wednesday class is off due to holiday. So no question? Okay, if there is no question, let us finish today's lecture. But before we close the class, Let me call your attendance, please. Response. Abu Abdullah, please respond quickly, okay? Abu Abdullah. Kamrul Islam Tushar.
Present, sir.
Okay. Imtiaz Hussain Shobhon. Abdullah Al
Present, sir.
Rifat. Imtiaz, are you there?
Sir, Imtiaz.
Okay.
Yes, sir.
Okay. Abdullah Al Rifat. Inamul Haq.
Present, sir.
Imam Reza. Rifaz present. Rokonujjaman Khan.
Yes, sir.
Bidhan Chandra. Laila Ishrat.
Yes, sir.
Farah Farzana. Fazle Rabbi.
Yes, sir.
Priyabrata Nath.
Yes, sir.
Ifat Rafsan.
Yes, sir.
Ali Ahmed.
Yes, sir.
Kaushik Devdas.
Yes, sir.
Murshida Jahan.
Present, sir.
Shakhawat Hussain. Samir Ahmed.
Present, sir.
Shakhawat, are you there? Shakhawat?
Present, sir.
Okay. Shakhawat present.
Present.
Samir?
Yes, sir. Present, sir.
Okay. Shakhawat present. Samir present. Okay. Mahmudul Hassan.
Present, sir.
Fahim Shakil.
Present, sir.
Abu Sajjad Ankon. Nibirujjaman.
Present, sir.
Sadman Shakib.
Yes, sir.
Adnan Kabir.
Yes, sir.
Dihan Pathan.
Present, sir.
Miraz Farooq.
Yes, sir.
Taki Yasir.
Present, sir.
Shahadat Hussain present. Rakibul Islam. Rakibul.
Sir, Rakibul sir
Al-
নেটে সমস্যা।
আছে। Okay, Al Shahriar. Al Shahriar.
আমাকে বের করে দিচ্ছে।
Tanvir Hassan.
Yes, sir.
Saqib Hussain.
Yes, sir.
Mashuk Alam.
Yes, sir.
Saqib, are you there? Okay, Mashuk
Yes, sir.
Alam.
Mashuki Alam. Yes, sir.
Shah. Okay, Mashuk present. Shah Alam.
Yes, sir.
Sabbir Sarkar.
Yes, sir.
Abrar Sadiq.
Yes, sir.
Ishtiaq Ahmed.
Yes, sir.
Khandokar Jahidul.
Yes, sir.
Abdullah Mofil.
Mufile, sir. Present, sir.
Oh, Mofile, sorry. Mahfuzur Rahman Sifat.
Yes, sir.
Shafiqul Islam Nirab.
Yes, sir.
Khandokar Sravon.
Yes, sir.
Khandokar Sravon.
Yes, sir.
Amanta Hussain.
Present, sir.
Abir Reza.
Yes, sir.
Amanta present. Amanta, are you there?
Yes, sir.
Okay. Abir
Yes, sir.
present. Okay. Okay. Khalid Ridwan.
Yes, sir.
Shahriaz.
Present, sir.
Tahmina Tanjin.
Present, sir.
Mahfuzur Rahman.
Yes, sir.
Fazila present. Ashrafun Nahar. Ashrafun Nahar.
Present, sir.
Okay. Shifa Chaudhuri.
Yes, sir.
Okay. Misbahul Alam.
Yes, sir.
Yasir Arafat.
Present, sir.
Sudeep Sarkar.
Present, sir.
Abu Kibriya,
Yes, sir.
Abdul Rahim. Abdul Rahim Shabbir. Okay. Okay, thank you. See you in the next class.
আসসালামু আলাইকুম স্যার।
Walaikum.
Assalamu alaikum, sir.
আসসালামু আলাইকুম।
Assalamu alaikum, sir.